Okay, this video picks up with question 6. Question 6 asks us to solve 3 separate exponential equations. The question on the test will actually only ask us to solve 2. And the first one here has a base of 2 on the left side. 2 is a prime number, so we can't factor this expression at all. We can't factor that base at all. But we then ask ourselves, well, can we write this side with a base of 2? And of course we certainly can, because 4 is 2 squared, and so we write 4 as 2 squared. Now both sides of this equation have 2 as a base, and we equate the exponents. X minus 3 equals 2 using the uniqueness property. We equate the exponents and we add 3 to both sides, and so x is equal to 5. In the second equation, the base on the left is 3, and that again is a prime number. We can't factor that, so we look at the right side of the equation and ask, can we write this expression as with a base of 3? And of course we certainly can, because 9 is 3 squared, so we write that as 3 squared, and now both sides of this equation have the same base, and so we can set the exponents, 2x squared plus 3x and 2, equal to one another. This entire expression, by the way, 2x squared plus 3x, that whole thing is the exponent, so that's what we use on the left side of the equation. And then we subtract 2 from both sides of this equation. We have a quadratic, and we can either solve that using the quadratic formula, or in this case by factoring. And so when we factor this expression, we have 2x minus 1 as our first binomial, and x plus 2 as our second. We then set each of these factors separately equal to 0. 2x minus 1 equals 0 means that if we add 1 to both sides and divide by 2, we have x is equal to 1/2. It's going to be a solution to this equation, and therefore this equation. And then for the other factor, it's just simply x plus 2 equals 0, so we subtract 2 from both sides. We have x is equal to negative 2, and so x equals negative 2 is a solution to this equation, and therefore to this equation. Then in part C, we have a base of e on the left side, and happily have e in our expression on the right, and so if we write 1 over e as e to the negative 1, then these exponents, x squared minus 2x and negative 1, are equal to one another, and we add 1 to both sides to give us x squared minus 2x plus 1, and that is a perfect trinomial square, which the handout that I posted Wednesday, I believe, goes over, and I can cover that more thoroughly in class if you'd like to see that. But that's x minus 1 squared. X minus 1 squared gives us this expression, so x minus 1 squared is equal to 0. And we take the square root of both sides of this equation. Of course, square root of 0 is 0, and the square root of a square are operations that cancel one another out, so we have x minus 1 equals 0, add 1 to both sides, and we have x is equal to 1. So that's the solution to that equation. And now for question 7, we are investing $25,000 at an APR, annual percentage rate, of 6%. We want to know what the value of the investment will be under each of the following 3 sets of circumstances. The first is after 1/2 year, so that means t is equal to 1/2, if interest is compounded weekly. Well, there's 52 weeks in a year, and so we fill in our formula. A is equal to P, the principal is P, 25,000, that's what we invest, times, in parenthesis, 1 plus the interest rate, which is 6%, and we convert that to a decimal by moving the decimal place here to the left 2 places. So it starts here, we move it to the left 2 places, and so that interest rate as a decimal is 0.026. We divide it by the number of compounding periods in a year, and since that's weekly compounding, then that's going to be 52, because there's 52 weeks in a year. And then we raise that to the M, which is the number of compounding periods per year, 52, times the number of years, 52 times 1/2. And if we enter that all into our calculators correctly, we come up with $25,760.92. Now, the value that we come up with is going to be several decimal places past this, but we round to the nearest penny. Now, our challenge in these questions is entering the values correctly into our calculators. Now, if you have a TI graphing calculator, then these are the keystrokes. These are the correct keystrokes for that calculation. You enter in 25,000 and times, multiply, times, and a left parenthesis, 1 plus 0.06 divided by 52, and close your parentheses. And then you use the exponent key or the caret key. If you have a TI graphing calculator, you should have this symbol among your available functions. And then you need a left parenthesis and a 52 times 1 divided by 2. Now, you may not need to do this. 1 divided by 2 is 1/2, is 0.5. And you can probably do that in your head. Plus, you may also be able to just say, well, 52 times 1/2, what's 1/2 of 52? 1/2 of 52 is 26. And so you would enter 26 in here directly. But if you want to enter in everything, you would need this parenthesis because the order of operations puts exponentiation ahead of multiplication and division, and so the calculator, if it saw this, would raise this value to the 52nd power, and then whatever string had come along will get multiplied by 1 and divided by 2. So that's why you need these parentheses. Now the Part B and Part C are the same, except that our compounding period is daily, so that means that M is 365 here, 365 here, and the term is 1 year, so that means we'll have a 1 here, and our keystrokes will be similar. They'll be similar to what we have up here. We probably know that 365 times 1 is 365, so these entries are probably superfluous, but I put them in just to emphasize the point that these are the strokes that you would use for this kind of calculation in a TI graphing. And finally, in Part C, we have a term of 5 years, so that means that 5 goes up here for T, and we're compounding monthly, and so 12 goes here for M, for the number of compounding periods, and these are the keystrokes for that. And you can see the approximations here, $26,545.78 for the 1 year compounded daily, and $33,721.25 for the 5 years compounded monthly. And finally, the last question in this group is uh, a similar question, except now instead of trying to find the amount that will be the yield at the end of the term, we want to find out how much we need to invest. What should our principal be if this is the amount we want at the end of the term? Well, the interest is 7.25%, and the compounding period is weekly, so we have 52 for the compounding period here and 52 for the compounding period here. We have a term of 10 years, and so we have a 10 for T up here, and our interest rate is 0.0725 because the decimal place was here, and we move it 2 places to the left to get the decimal representation. Then we divide both sides of this equation by all of this, so 12,000 divided by all of this, to find out the principal that we should invest. Now, if you want maximum precision and you want to do this all in one step, then these are the keystrokes you would use. 12,000 divided by, and then you need a set of parentheses for the denominator. The entire denominator needs to be enclosed within a set of parentheses. That's why I made them larger, bolder, and blue. That emphasizes that everything in blue is this denominator. And then the other keystrokes are similar to what's up here in this part of the calculations in question 7. But if you enter all of these, you make all these entries into your calculator and hit enter or equal, which is what you should do at the end of this and this calculation, then you should have a principal of $5,814.83.